All right, so I do want to provide this. This is not necessary for the Econ 2500 class, but just to show you how we actually solve our beta naught hat and our beta 1 hat and go and work through it throughout the whole process. So the first thing we want to think about is this is called OLS, or ordinary least squared. It's also called sum of squared errors. And the reason we call it sum of squared errors is because the method we're going to use to be able to solve for beta naught and beta 1. So our sum of squared errors means we first solve the equation for our error term. So we get ui is equal to yi minus beta naught minus beta 1 xi. And now we're going to square each side and then take the summation of each side. And our goal is to minimize this. All right, so to minimize, we want to take derivatives instead of them equal to 0. Okay, so here we want to choose beta naught and beta 1, so that's a variable that we get to choose. So our first order condition is to take the partial derivative of the sum of squared error with respect to beta naught. Okay, and this is where it's going to require some use here. This is going to require the chain rule, which we actually didn't use in class. But with that, we're going to take the exponent out in front times the whole thing, yi minus beta naught minus beta 1 xi, times the derivative of the inside, which on beta naught is just negative 1. And we set that term equal to 0. That's our first order condition. Our second one is to take the partial derivative with respect to beta 1. Well, that's going to be similar. We take the 2 out in front, summation of yi minus beta naught minus beta 1 xi, and now we take the derivative of the inside, which is negative xi, and set that equal to 0. All right, so that's our two equations that we want to go about solving. And so the question is, how do we go about solving those? Well, let's go ahead and solve this one first. Is I can divide each side by negative 2. So going from first equation, by dividing each side by negative 2, I get the summation of yi minus beta naught minus beta 1 xi equals 0. I now multiply each side by 1 over n. So that goes to 0. So now, and I'm going to factor the summation through. I get 1 over n summation of yi minus 1 over n summation of beta naught minus 1 over n summation of beta 1 xi equals 0. Okay, well, summation of yi times 1 over n is y bar minus 1 over n. Now there's no I on beta naught, so that's just n times beta naught, so that's just beta naught minus, bring the beta 1 out in front, and we get x bar, beta 1 x bar, and so this equals 0. So now we have y bar is equal to, rather solve for beta y bar, let's solve for beta naught. So beta naught is equal to y bar minus beta 1 x bar. Okay, and that's what we got for that. Now the question is, because we're taking this derivative and estimating it, this is actually going to be the estimated beta naught hat, and this is going to be the estimated beta 1. So that's how we get that. Now, what is the next step? So we solve for beta naught hat. Now we need to look and be able to solve for beta 1 hat. So we want to come here and be able to solve for beta 1. So our second order condition, I'll start it, let's see, right up here, tells us that, so I'm going to divide each side by negative 2 and then multiply by xi, so I'll get summation of yi, write it this way, minus beta naught minus beta 1 xi times xi equals 0. And now I'm going to distribute that xi through, so I get summation of yi xi minus beta naught xi minus beta 1 xi squared equals 0. Okay, now I can break apart the summation. Or actually, before we do that, let's just try it this way. Instead of summing that part, let's go ahead and put in what we have for beta naught. I think that's going to be the best way to go about doing it. So we get the summation of yi minus, now we put in beta naught, y bar minus beta 1 hat x bar minus beta 1 hat xi times xi equals 0. Okay, and that's going to be a little more helpful as we look at it. And so what we can do is try to separate the beta 1s all by itself. So we'll get the summation of yi minus y bar. Okay, so that's right there. And we can multiply that by xi minus the summation. All right, so now we have this beta 1 and that beta 1. So we'll get x bar minus xi. Let's make sure we get these negatives. So that was there. So it'll be positive x bar, so plus x bar minus xi beta 1 hat times xi equals 0. And now I'm going to bring this to the other side. So I get summation of yi minus y bar times xi is equal to negative summation of x bar minus xi times xi, and beta 1 hat is in front. Now I can take that negative sign through and get the summation of yi minus y bar times xi is equal to beta 1 hat summation of xi minus x bar xi. Now, through some statistical higher properties, we can rewrite this term here as the summation of summation of yi minus y bar xi minus x bar. That's that term. And now we're going to divide it by this term, which is equal to summation of xi minus x bar squared is equal to beta 1 hat. So the way we went from this step to here is through a statistical property, which allows us to do that. And same thing with this step here. And so now beta 1 hat is equal to covariance of xy all over variance of x. And so that's how we actually do the first order conditions and solve for what we have. So here's the key, the end note, and this is what we just wrote down. We went straight from this step and said, hey, you can get it here. And that's how you actually go about doing that.